So, hello everybody, this is a physics analysis from a movie called Bahubali 2, a Hindi or Telugu film, the highest grossing Indian film worldwide. So, the film follows the story of a person named Shivu, a tribal young man who learns about his royal heritage and his father's bravery. He sets out to find his father's killer and reclaim his throne. So, there are many battle sequences in this movie where Bahubali, or Shivu, who's the protagonist, is shown using the laws of physics to fight against his enemies, while the antagonist named Balaladeva tries to cheat him and betray him. So we're gonna watch the scene. The description of the scene. So the army was stranded outside of the walls of the fort, and Bahubali uses palm trees to catapult his army to the top of this fort to fight the enemies. A group of 10 men uses a pulley attachment to the ground and a rope system to pull a palm tree to the ground, which is later anchored by rope. A group of 6 soldiers with body-sized shields, including Bahubali, climb onto and stand on the tree holding onto each other in a linear pattern. One of the soldiers cut the rope anchor and sends them flying over the walls of the fort. During flight, they assemble into a human cannon with their shields faced outwards. Their shields prevent them from getting shot by flying arrows. When they land on the fort, the soldiers split and start fighting the enemies. After the scene, many more human cannonballs arrive. So the questions we'll try to answer are, can the soldiers survive the G-force acting on them during launch? Is the force thrown by the palm tree enough for the soldiers to reach the top of the fort? And even, can the soldiers survive the landing on the top of the fort? And finally, if this movie scene can even happen in real life. And we'll use these values, velocity, acceleration, projectile motion, forces, Newton's laws of motion, and the law of conservation of energy to find answers to these questions. So before we start calculating and analyzing, we need to find the values. So for the height and range, we're going to use the height of the palm trees. If a mature palm tree is 15 meters high, then the height of the fort would be 60 meters. Taking into account that I'm looking at a camera angle and how a palm tree close to us is larger than a palm tree that's further away. And so if the fort is 4 palm trees high, then the height of the fort is 60 meters. To find the max height reached after launch, a total of 5.5 palm trees if the soldiers reach the tip of the watchtowers, and which comes down to 82.5 meters. And for the range, it's about 6 palm trees away, and that's 90 meters of range. And for the launch angle, it's 60 degrees according to the protractor. So the first question is the force thrown by the palm tree really enough for the soldiers to reach the fort? And we're going to start our calculations. So to calculate the range after launch, to find out if the soldiers will even reach the top of the fort, we need to remove the range, which is an assumption from the movie, and we need to solve for that. And so next, some missing variables will have to be found in order to find the range. And so the first kinematic equation is used to find the initial velocity in the x-axis, which is 50.8 meters per second. Next, the initial velocity on the x-axis is found using tangent 60 degrees, initial velocity y divided by initial velocity x, and you get 29.3 meters per second. And then the initial velocity on the x-axis is used to find the displacement with a simple equation, which is v equals to d over t. And so the range is found to be 300 meters, which far exceeds the predicted range by the movie. It's by 3 times. But due to air resistance, you can expect the human cannonball to reach a lesser range, but it still far exceeds the 90 meters of range from the movie. So, question 2. Before actually launching, can the soldiers survive the G-force acting on them during launch? So, we have some values from our assumptions and what we calculated before, but still, some values will have to be found through calculations. The initial velocity is found from the v initial velocity in the x-axis and initial velocity in the y-axis using Pythagorean theorem, and you get 58.6 meters per second. The acceleration of the projectile needs to be found. So the acceleration of the projectile is equal to the acceleration of the tree during launch. So the initial velocity of the projectile is the final velocity of the tree that launches the soldiers. From the scene, the time taken for the tree to move from a bent position to a straightened position lasted about 0.84 seconds. So with the acceleration formula, an acceleration of 69.8 meters per second square is calculated. And after dividing that by the force of gravity on Earth, it comes to about 7.12 Gs. So, according to ChatGPT, 7Gs acting on the human body for 0.84 seconds will not cause death, but it'll cause immediate health problems that will paralyze the soldiers. The soldiers might still survive during launch, but still, there is some more analysis to be done. The soldiers are launching into the air when standing on the palm tree, and when launching, such a high force can cause significant damage to the lower body. According to Newton's first law of motion, an object will stay at rest unless acted upon by an unbalanced force. So, looking at the picture, or as you remember from the scene, the soldiers are slightly squatted. When the tree is unanchored, the body will stay at rest, and the tree will only move the lower body. This immediate acceleration is way too fast for the soldiers to react, which causes the lower body to hit the tree. It takes about 4,000 newtons of force to break a femur, according to an article. And since the human body has two femurs, it'll take about 8,000 newtons to paralyze both legs. So according to the calculation, 8,000 newtons of force will be applied, which will definitely immobilize the soldiers, as well as sustaining several serious injuries or even death. So, for our third and final question, say that the soldiers survive the launch and accurately reach the top of the fort. Can the soldiers even survive the landing? And also, what is the force upon impact? So, here are some values that we already found before, and we need to calculate for deceleration upon impact. So, a final velocity of 28.78 is calculated using the law of conservation of energy and the energy equations. So, immediately after the soldiers were launched into the air, they had a gravitational potential energy and kinetic energy. And when the soldiers reached the fort, they were high above the ground because they're on the fort and were still moving, so they had a new gravitational potential energy and kinetic energy. This equates to E mechanical at launch is equals to E mechanical at impact. During impact, the final velocity is actually the initial velocity. This is because when the shield come in contact with the ground, it's still moving at 28.78 meters per second. The actual final velocity after impact is 0 meters per second because this is when soldiers disassemble and start fighting on the fort. Therefore, this final velocity is used as the initial velocity to find the deceleration during impact. The third kinematic equation is rearranged and is used to find the deceleration of the soldiers, which comes to be about 828.3 meters per second square. When this deceleration is divided by Earth's gravitational pull, it's about 85 Gs. So, according to a website, the highest G force a human male can ever take, and might still survive with several injuries, is 75 Gs. But with 85 Gs of deceleration upon impact, it's 100% fatal. In Newton's second law of motion, we can figure out the force acting upon them upon impact. So if all the soldiers together weigh about 690 kilograms and decelerate at 828.3 meters per second squared, each soldier will experience about 95,300 newtons of force. And with common sense, we can find out that it's immediate destruction of all the soldiers during impact. So, does this movie scene work in real life? Obviously not. The soldiers will not survive at any point of the scene, but in the world of Bahubali, of course they will survive and make it to the top of the fort in perfect condition. Thanks for watching.